So, good morning, everyone, and welcome to this lecture. In this lecture, we are going to wind up our interference and YDSE part. If we have a look at what we did in the last class, we were solving some questions based on the Young's double slit experiment, and we will be doing some more questions from the previous year papers as well. Let us start with this one. The first question for today, and the question is here. I'm trying to put all types of questions that cover all types of formulae, all types of concepts that can come. And this is the first question for you. In the Young's double slit experiment, light of wavelength 4000 Armstrong unit is used, and fringes are formed at a distance of 2 meter. The fringe width is 6.6 mm. If the entire apparatus or the entire experiment is performed in a liquid of refractive index 1.5, then what would be the width of the fringes? I'll give you a minute to solve it. 0.4 mm is correct. How did we get this?
Sir,
I-
if we keep that whole system in water, then fringe width will be uh, is inversely proportional to mu.
So fringe width in the medium will be equal to fringe width in air, which is 0.6 divided by the refractive index. Refractive index is 1.5, and you end up with the answer 0.4 mm. We all get this?
Yes, sir.
Okay, good. Next one. Any one of this question is going to come in your exam, trust me. This is the next one coming on your screens now. Two identical sources emit waves which produce an intensity of K unit. I think we have done this. When the path difference is lambda, what will be the intensity at a point where path difference is lambda by 4? I think we have done this question previously when we were discussing intensity. We have done this, yes or no?
Yes, sir.
Yes, so let us, I forgot it. I saw the same question. Let me put the next one. And the next one is this: a thin mica sheet of thickness 2 into 10 raised to the power minus 6 meter. Refractive index 1.5 is introduced in the path of the first wave, the upper wave. The wavelength used is 5000 Armstrong unit. What will the central maxima shift? So what will be the number of fringes it shifts? Number of fringes. I think I had given you the formula. What is the formula of number of fringes shift?
Mu minus 1 into T by lambda, sir.
As you can see, here we have the formula mu minus 1 times T by lambda. Yes or no?
Yes, sir.
Number of fringes. We just have to put that formula. Remember, it's a test of your speed. So I just put the formula mu minus 1 times T by lambda. Mu is 1.5, so 1.5 minus 1. Thickness is 2 into 10 raised to the power minus 6 divided by the wavelength, which is 5000 into 10 raised to the power of minus 10. So how much you are going to get?
2, sir.
2. Then how do you know it is 2 fringes upwards or 2? Yeah, so you are going to get 2 straight away.
He is given in the first wave, so it is upper one.
Yes, so normally the first wave refers to the top one, so it will be 2 fringes upwards. Do we understand this?
Yes, sir.
Well done. As you can see, if you pay enough attention in the class, same question is going to appear in your exam. And here is an example. This is a question taken from 2023, first Feb, shift 2. And this is the question, and I think you can give me the answer straight away for this one. This is 2023, first Feb, shift 2. In a YDS setup, number of fringes shift.
Sir, option 2, sir.
Option 2, sir. As you can see, it's a straightforward answer. These are the type of questions that you are going to find in the examination hall. Trust me on that. So please, 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 pay attention to what we are doing in the class. If we pay enough attention in the class, the questions from the class are going to appear in the exam. Again, this is an example of the same thing happening. This is the question from 2029 mains. As you can see, the same thing comes, maybe in a different way. In a double slit experiment, when a thin film of thickness T having refractive index mu is introduced in front of one of the slits, the maximum at the center of the fringe width shifts by one fringe width. What is the value of T? 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 And the answer is
Lambda by mu minus 1.
lambda by mu minus 1. As you can see, things and life gets pretty simple if we just do simple things correctly. Are we able to understand this?
Yes, sir.
Let's have this one here. You can see, once you understand this, you will be confident enough to solve any question that comes in the exam. This is again a question from 2019 JEE mains. I'll give you the time to read the question, give me the answer, and then stay happy. Yes? What is the option?
Option D, sir.
Option D, sir. And how did you get that, sir? If I give you the formula that we had seen, number of fringes shift n. What was the formula, beta?
It is number of fringes, so mu minus 1 into T by lambda, sir.
Mu minus 1 into T by lambda. So from there, what is the value of T, my dear friends?
N lambda by mu 1, mu minus 1.
That is the answer, my dear friend. Does it match any of the options? No. No options are correct. The question was probably wrong, or maybe one of the options is missing. This is the correct answer, my dear friends. If you're not confident enough of what you know, well, no one can help you. This is the correct answer. N lambda upon mu minus 1. Do we understand this, or this is going above our head saying bye-bye?
Understood, sir.
Pakka, sir?
Yes, sir.
Pakka na, sir?
Yes, sir.
Okay, sir. I understand this is Pakka, sir. So now let me present to you this revolutionary question from your 2023 paper. 2023 paper. This is 30th January, shift 2, and I will not waste any time. And I'll give you the time to solve it. Meanwhile, I look for the questions. The time starts now. Okay, so I must solve this. Resultant intensity I is given by 4 times intensity of the source cos square phi by 2. That is the formula. I hope you remember this formula. They are waves of the same intensity. When the path difference is 0, the resultant intensity is I naught. So if I put the value, I naught will be equal to 4 times intensity of the sources. That is the first case. Yes or no?
Yes, sir.
In the second case, the part difference is lambda by 2. So what is the phase difference?
Pi, sir.
Pi. Cos square pi by 2 is how much?
0.
0, my dear friends. 0, my dear friends. 0, my dear friends. 0, my dear friends. So in that case, I will be equal to 0. Yes or no?
Yes, sir.
Sorry, I1. It will be I1. It's misprint probably. I1 will be equal to 0. In third case, part difference becomes lambda by 4. So what is the phase difference?
Pi by 2, sir.
So what is cos square pi by 2 into 4i?
It is 1 by root 2.
We need to take deep breaths. Close your eyes for a moment. Then open your eyes. Cos square 45 is 1 by 2 multiplied by 4 is. I2 will be equal to how much? Now give me the answer.
2 IS, sir.
See, now you get the correct answer. Now we can find out the value of I1 plus I2 divided by I0, and the answer is
1 by 2, sir.
1 by 2, sir. 1 by 2, sir. 1 by 2, sir. 1 by 2, sir. 1 by 2, sir. And 1 by 2, sir. That is the answer, sir. I hope we have understood this. Do we understand this?
Yes, sir.
I'll give you one more on this type. This is from 2019 JEE. I'll give you time to read the question, give me the answer, and then stay happy. Well, it's a question on diffraction, I guess. We have not discussed diffraction, so we will let it pass and we'll move on to the next question. I think I gave you the wrong question. I was supposed to give you the question which was after this, not this one. In a haste, I did the mistake of giving you the question which I should not have given. Anyways, we'll solve that question once we get on to diffraction. This is the question that I was supposed to give you, matching the question that was there in the previous question. In a Young's double series experiment, the path difference at a certain point between two interfering waves is lambda by 8. The ratio of intensity at this point to that of central maxima. Do it fast.
So it is option C, 0.94.
It is option
C, sir.
Option C. I have the answer as option D. Well. Let's see. Okay, so intensity at any point will be 4 times intensity of the source cos square phi by 2. Yes or no? Yes or no?
Yes, sir.
The intensity of the central maxima, if I call that central maxima as IC, that will be 4 times of IS. Yes or no?
Yes, sir.
We all know this. So I can write this formula as I will be equal to IC cos square phi by 2. This is again one of the important ways in which you can remember this. Do we understand this?
Yes, sir.
So I have to find out the ratio of I by IC, and that I by IC ka ratio will be equal to cos square phi by 2. You just have to find out the value of cos square phi by 2. If the wave, if If the path difference is lambda by 8, what is the phase difference?
Lambda by 4. Sorry, pi by 4.
Pi by 4. Then 5 by 2 becomes
Pi
pi
by
by
8.
8. Do you know the value of cos pi by 8?
Sir, it is, I think, root 5 minus 1 by 4, I think.
So either you should be able to calculate the value of cos pi by 8. Once you calculate it, I think the answer that you're going to get is 0.85. But there is one more way in which you can do this. So if this question comes in this way, if you are not able to calculate the value of cos of something, but you know the value of cos pi by 4, yes or no?
Yes, sir.
I could use the original formula. The original formula I was I1 plus I2 plus 2 times root over I1 I2 cos phi. Do we remember this original formula?
Yes, sir.
So once sometimes you get caught in pi by 8, cos pi by 8 you don't know, cos pi by 4 you know. Now you can put the values here. This is the reason which I did this question. So this will be I naught plus I naught plus 2 times I naught cos of pi by 4 we know that is 1 by root 2. So the answer will be I naught plus I naught plus root 2 I naught. So this will become, I think, 3.4 times of I naught. Yes or no?
Yes, sir.
Where I naught is the intensity of the source. Now you have to find out the ratio of I divided by IC, and IC will be 4 times. So basically you have to find out the ratio of I divided by 4 times I naught. Yes or no?
Yes,
So
sir.
I divided by 4 times of I naught will be equal to 3.4 divided by 4, and you end up with an answer which is close to this one. Do we understand how I got this one?
Yes, sir.
Yes or no?
Yes, sir.
No or yes? Everyone
Got it.
got this?
Yes, sir.
Do we understand how I got this one?
Yes, sir.
Okay, let me move on. That was the reason I did this. Remember, there is no way a question can come which you don't know how to solve. The only thing you have to remember is that you know it. You may not have done a question which looks similar to this. I'm making sure that any question that comes will not ever surprise you in any topic that we have discussed. Covered almost all types of questions which can probably come. This is a question from 31st Jan, shift 2, latest JE. Two wavelengths, lambda 1 and lambda 2, are used in a YDSC experiment. Their maxima coincide at certain position. I told you about white light. Sometimes the maxima may coincide, sometimes maxima of one may coincide with the minima of the second. Their maxima coincide at a certain location. Find the minimum separation between such a location and the central maxima. Oh, 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 oh. How will you do this? I'll give you 2 minutes to think about it. So how are we supposed to find out? Both of their maximas, certain maximas, coincide at some point. So at that point, I can write n1 lambda 1 d by d, which is the position of the n1 minima of the first one, that should be equal to n2 minima, n2 maxima of the second one. Do we understand this?
Yes, sir.
So n1 into 600, so that is 6n1 will be equal to 8n2. Do we get this?
Yes, sir.
I've seen a lot of problems where this thing comes. 6 times n1 is equal to 8 times n2. You have to find out the minimum values of n1 and n2, which satisfies this equation. What will be the minimum value of n1 and n2 which can satisfy this equation? It is very simple to understand this. I can write n1 by n2. Oops. I can write, my dear friends, n1 by n2 will be equal to 4 by 3. Yes or no?
Yes, sir.
So the minimum value of n1 can be 4 and the minimum value of n2 can be 3. Yes or no?
Yes, sir.
That is the minimum value where this can coincide. Now what is that minimum value? You can put, oops, you can put this 4 in this equation, or you can put this 3 in this equation, and you will get the position of n1 minimum, n1 maxima of the first one, or n2 maxima of the second one, and they both will be at the same position. So I can just put the value of n1 as 4. Let us see. So 4 multiplied by 600 Armstrong, 600 nanometer, multiplied by d divided by 0.35 into 10 raised to the power minus 3, and you will get your answer. The answer that is given to me is 48. Do we get this? 48 mm or something like that. Do we get this?
Yes, sir.
Have you understood how this question was solved? Yes or no? No, yes.
Yes, sir.
Have you noted it down? Have you noted it down?
Yes, sir.
This is the next one. As I told you, it is not necessary that we only introduce a glass slab in one of the slits. I can introduce glass slab in the bottom slit as well. This is a question, a similar question has come in a JEE. I'll give you time to read the question, give me the answer, and stay happy. Remember, here it is not mentioned if the thickness of both the glass plates. So we'll assume that thickness of both the glass plates is same. Do we understand this? Do we understand this?
Yes, sir.
Thickness of both the plates are same. Option A, 8 microns is the correct one. Because of the first plate, what will be the shift?
Mu1 minus 1 into T1 by lambda.
Mu minus 1 into
T by lambda, sir.
T by lambda. That was the number of fringes shift, no?
Sorry, it is beta into beta.
Yes, into beta. Correct. And x2 will be mu2 minus 1 into T by lambda into beta. Yes or no?
Yes, sir.
The central fringe takes the position of the fifth bright fringe. So mu2 is more, this one is more. So x2 minus x1, we will take it as mu2 minus mu1 into T by lambda into beta. That should be equal to 5 times the fringe width. Yes or no?
Yes, sir.
And the fringe width is beta. Yes or no?
Yes, sir.
So from there, beta will get cancelled, and you will get the value of thickness T. The value of thickness T will be equal to 5 lambda upon 0.3. Yes or no?
Yes, sir.
Once you put the value, you should get the answer as 8 micron. Everyone understands this? Yes or no? No, yes.
Understood, sir.
And I can see a replica of this question that appeared in your shift that you gave. This was, this is the question that appeared. This is 30th Jan, shift 1. Now give you time to get me the answer for this one and stay happy. Sir, it is 1000. The option were 10, 15, 8 and 12. Number of 15. 1000. I could not get the option because there was no space. Option was 10, 15, 8 and 12. Does it change your answer?
Sir, it is 10, sir.
It is 10, sir. So the shift x1 will be mu1 minus 1 into t1. Remember, to find the shift, it is mu1 minus 1 into t1. Yes or no?
By lambda, sir.
That is, again, you are getting confused. Remember this formulae, you're just getting confused. How much fringes are shifted? Just remember this. The fringe shift is given by mu minus 1 into t lambda. Number of fringes is mu1, mu minus 1, t by lambda. This is the number of fringes shift. Number of fringes that has shift. How much it shifts upwards or downwards is given by this formula. Remember this, okay?
Okay,
Do
sir.
not get confused between the two, okay? Every time I think that you are getting confused. So the number of fringes, you have straight away you have to find out the number of fringes shifted. So straight away you can just write the number of fringes shifted in the, due to the first slit will be this one, and number of fringes shifted due to the second will be this much. Yes or no?
Yes, sir.
So which is more? I think in the downside it is more. Yes or no?
Yes, sir.
So the number of fringes shifted n will be equal to mu2 into t2 minus mu1 into t1 divided by lambda. Yes or no?
Yes, sir.
And this number of fringes shift is given. That is what you have to find out. So you just multiply it and divide it. You can do this, yes or no?
Yes, sir.
And I think you will end up with the answer of 10 fringes. 10 is the number of fringes that has shifted. That takes us to the last question of this class, which is again from one of the shifts of your exam. This is 29th January, shift 1. And the question looks like this. Why is the question not coming? In the standard YDAC, first minima is obtained in front of the slit for lambda is equal to 800 Newton meter. If the distance between the slit and the screen is 5 meter, what is the distance between the slits? Okay, then, if you don't have any doubts, then I will wind up this class here, and I'll see you tomorrow and we'll wind up wave optics. Take care. Have a nice day.
Bye.